The daily profit of an oil trader is given by the profit function P equals 96x minus 0.03x squared, where P is the daily profit in euro and x is the number of barrels of oil traded in a day. Part A, complete the table below, so we need to fill in the gaps. Part B, draw the graph of the trader's profit function on the axis below for x greater or equal to 500, less than or equal to 2,500, and x is an element of OR, so x is an element of the real number set. Part C, use your graph to estimate 1. The daily profit when 1,750 barrels are traded, and 2. The number of barrels traded when the daily profit is €60,000. Part D, 1. Use calculus to find the number of barrels of oil traded that will earn the maximum daily profit. And 2. Find this maximum profit. The trader will not make a profit if he trades more than K barrels of oil in a day. Calculate the value of K. So this is the graph that we're going to use to answer part B. The x-axis represents the number of barrels of oil, and the y-axis represents the daily profit in euro. So part A, complete the table below. So our function is P equals 96x minus 0.03x squared. And we can either use our table function on our calculator, or we can substitute in place of the x values individually. So I've done that down here. So I'm starting off with 1,000 for my x value, and I'm swapping both of those x's for 1,000 with brackets around it. Very important that we've brackets around it. So I get 96 times 1,000 minus 0.03 times 1,000 squared, and that gives me 66,000. So that's going to be my first P value there. If I sub in 1,500 in place of both x's, I get 76,500. If I sub in 2,000 in place of both x's, I get 72,000. And if I sub in 2,500 in place of both x's, I get 52,500. So now I've completed my table. Part B, draw the graph of the trader's profit function on the axis below for x greater or equal to 500, less than or equal to 2,500, where x is an element of OR. So our first x value is 500, and our first p value is 40,500. So we go across to 500 on the x-axis, and up to 40,500 on the p or y-axis, and we plot our first point. So that's the first red dot. Then we have an x value of 1,000 and a p value of 66,000. So we go across to 1,000 and up to 66,000. Plot our next point, that's the second red dot. Then we go across to 1,500 on the x-axis and up to 76,500 on the y-axis. So across to 1,500 and 76,500 on the y-axis, that's our third red dot. Then 2,000 on the x-axis, 72,000 on the p-axis. So across to 2,000 and up to 72,000. And then 2,500 and 52,500. So across to 2,500 and up to 52,500. And we plot our last point. And then we join them together with a pencil, making sure that it's curved along the top. Part C, use your graph to estimate the daily profit when 1,750 barrels were traded, and the number of barrels traded when the daily profit is €60,000. So what we do is we go to 1,750 on our x-axis, which is about here. We draw a line straight up with our ruler until we touch our graph, and then we draw a line straight across until we get to our y-axis or our p-axis. So we get to 75,000. So then we go to 60,000 on our p-axis or our y-axis, and we draw a line straight across, and it crosses the graph in two places. So we drop two perpendiculars straight down to the x-axis, And the first one comes to around 800 and the second comes to around 2,300. It's very important that if they ask us to use our graph, we actually draw on the graph. Part D, use calculus to find the number of barrels of oil traded that will earn the maximum daily profit. So we have P equals 96x minus 0.03x squared. So we have to find the derivative of our function P. So what we're going to do is cancel out the x with the 96x, so we just get 96. The derivative of 96x is just 96. And then to differentiate minus 0.03x squared, we bring the 2 down in front and reduce the power by 1. So it's going to be minus 2 multiplied by 0.03 x, because 2 minus 1 is 1 and x to the power 1 is just going to be x. So the 2 came down in front and it gets multiplied by what's in front of the x. So minus 2 multiplied by 0.03x is going to be minus 0.06x. So now what we want to do is get the x on its own. So we're going to minus 96 to both sides, so that'll cancel out. So we get minus 96 equals minus 0.06x. And then to get the x on its own, we have to divide across by minus 0.06. And minus 96 divided by minus 0.06 is going to be 1600, which is equal to x. Therefore, 1600 barrels will earn the maximum daily profit. Part 2, find this maximum profit. So what we have to do is substitute x equals 1600 into the function p. So we got that from the previous question. So our function p is 96x minus 0.03x squared. So we swap that x for 1600 with brackets around it, and we swap that x for brackets with 1600 with brackets around it as well. 96 multiplied by 1600 minus 0.03 multiplied by 1600 squared gives us 76,800. Therefore, the maximum profit is €76,800. Part E. The trader will not make a profit if he trades more than K barrels of oil in a day. Calculate the value of K. So we have our function P equals 96x minus 0.03x squared. And what we have to do is let it equal to 0. So step 1, let the function P equal 0. Step 2, we have to factorize. So we see what's common to both of these, and it's going to be an x, so we take the x outside the bracket. X into 96x leaves us with 96. X into minus 0.03x squared leaves us with minus 0.03x, and this is still equal to 0. Step 3, we solve, which means get the x on its own. So this x just gets let equal to 0, and then what's inside the bracket also gets let equal to 0. So we have 96 minus 0.03x equals 0. The first thing we do is we get rid of the 96, so we're going to minus 96 to both sides. So we're left with minus 0.03x equals minus 96. And then we divide across by minus 0.03 to get the x on its own. So minus 96 divided by minus 0.03 gives us 3,200. So x is equal to 3,200, which means there are 3,200 barrels equal to K.